Hello everybody, I'm Captain MAMGAIN. Now that we have talked about position, the measurements for distances, let's get down to course, direction. You're in the middle of the ocean somewhere, nothing in sight, you are asked to proceed to some place. Which way are you going to go? Direction. You should know your direction. Now, which way is determined by the point you are aiming for. If you are in some place and you are aiming for another place, so this is your direction. But what is my direction? Which is which way? So you should have some reference point, some datum or some fixed point from where we can measure our directions. And we have learned of some important points like north, south, east, west, and it has been conveniently taken as north has been taken as the scale for measurement of our directions. North, which is referred to as true north or sometimes even called due north. Now, when you're deprived of any visual indication near you, you lose all your senses of direction. So, to help us out, see, we have compass. And this is a compass card, what I'm showing you here. The compass is divided into 32 points, and the points are shown here. And it is 360 degrees right round. And we know that degrees, converting degrees into minutes and to seconds. Now we do not talk much about seconds, it's all in decimals. So you can always divide your seconds by 6 and you get your decimal here. Divide 36 by 6, you get 0.6. 54 by 6.9 and so on. We take north as our reference point, which is called 000, though it's not been shown as 000 here. It is what we call three-figure notations. All these, when we are talking about courses, we never talk in terms of 10, 20. We talk about 0, 10, 020. And that is what you should always be using. Your course, if you're steering 4 degrees, your course is 004. Three-figure notations. The other way to do it is a quadrant system. In quadrant, we measure the angles from north or south, towards east or towards west. It's never from east or west. Now here, like I've given you an example here, 340 degrees, 340, making an angle of 20 degrees from north towards west. So I call it north 20 west. Similarly, 280, it is making an angle of 80 degrees from north towards west. I call it north 80 degrees west. This is an important uh, way of converting your taking your courses, because this conversion would be required when we go about solving some questions further up. So you should be conversant about how to go about converting your three-figure notation into quadrant form. There are two types of compass in use nowadays for us. One is a gyro compass, which is an electrical instrument which depends upon some mechanical and dynamic laws, which I'm not inclined to talk here. And it is designed to be pointing towards true north. The second compass, which all of us know right from our childhood, is magnetic compass, which is functioning on Earth's magnetism. And we know that different type of materials are affected differently by Earth magnetism. And a freely suspended magnetic needle, influenced only by the Earth's magnetism, points towards the magnetic poles. That's the magnetic north or magnetic south. Geographical poles we have already talked about earlier, that wherever the axis meets the Earth's surface, 2 points is north and south. I have omitted the incline here because just for understanding here, incline will come later on when we get down to astronomical navigation. And as I said, true north and true south are the 2 points where the axis meets. A compass, arrow compass is designed to be pointing towards north. And all the lines, what we had learned earlier, great circles, semi-great circles which join north and south pole are called the meridians. So the meridians would be the true north and south direction. As you can see here, the meridian points towards north and south. So meridians are always pointing towards true north and true south. And gyro compass is designed to be pointing towards true north and true south. Two points would be called being due north and south of each other only if they are on the same meridian. If they are on different meridians, then the 2 points would not be due north and south. To be due north and south, you got to be on the same meridian or same longitude. If you have got to go from A to B, you are aiming for B, that would be a course. Now, if this was measured from true north, as the angle showing here is about 80 degrees, you can see 80 degrees. Now, this would be your true course. True course is the angle which is being made at the ship's head or along this coastline here from true north. That's your true course. 080, measuring it from true north. If these readings were read from gyro compass or magnetic compass or a compass as I've written down here, we'll distinguish between compass and a magnetic compass a bit later. So they can be denoted as G, M or C instead of writing the full thing here. So G stands for gyro, M for magnetic and C for compass. This I have taken it from true north, my course is 080 degrees true. Now, of course, in this I have been talking only about courses, but whatever I have talked here even is relevant to all these things what I'm talking here, heavenly bodies or terrestrial objects. So when you are aiming towards a heavenly body or a terrestrial object, the terms what we use instead of course is azimuth or bearings. Azimuth we'll be discussing a bit later. Bearing is the angle at the observer between, I've written down true north, magnetic north or compass north depending upon what compass you have used, and the line joining the object. So this being taken from true north, I'm calling it as true bearing or true azimuth. Azimuth, as I said, we'll discuss a bit later. And this angle is being formed here at the observer. And the observer is considered to be here, right in the center of the compass card. So whatever we are talking now about gyro compass and other things are relevant to heavenly bodies as well as terrestrial objects. True course we said 080. Gyro is designed to be pointing true north. If I was reading it from gyro, I'm still getting the reading as 080. But as I said, this is an instrument. And as you all are aware, that instruments are susceptible to some errors. If there is no error, then the gyro course and true course would be the same. But being an instrument, there are possibilities of having some error. And if you're reading it from gyro compass, then we talk in terms of gyro course or gyro bearing. So we just use the word G there. Don't have to write the full thing. Gyro course also means G means gyro. Course 080. True. I'm reading it off gyro compass. With gyro compass it is 090. Same course is 090. That's basically because the gyro north and true north, they're not pointing towards each other. You can see that there is a difference of 10 degrees here, 10 degrees here. Because gyro compass is not pointing towards true north, this is the error in the gyro. Error is 10 degrees. True north is the angle, true north 080. If I was reading it off gyro compass, the gyro north pointing somewhere else, I'm getting the course as 090. Gyro course 090, gyro, or just as I said, I write down G. And for true, I just write down G. So there's a difference of 10 degrees between gyro north and true north. Gyro error, true is 80, gyro is 90, it's 10 degrees. It is reading, the gyro is reading 10 degrees more than the true. So when it is reading more than the true, then we call it as gyro error as high. And we, instead of writing full high, we write down just H. So if the gyro is reading more than true, the error is high. So the gyro error is either low or high, depending upon what it is reading. Now these some questions would give you a look into this. Gyro is reading higher than, gyro reading is higher than the true, then the error is high. The gyro reading here is 321, true is 319. I say the error is 2 degrees high. Similarly, gyro is 088. They gave me an error of 2 degrees high. So gyro is reading higher than the true. So the true would be 068. If the gyro is reading less than the true, then we call it low or just L there. Gyro is reading 313, true is 315. Gyro is reading less. Gyro error is 2 degrees low. Gyro is 115, error is 2 degrees low. That means it is reading less than the true. So the true would be 117. So gyro error higher than gyro. Gyro error if reading higher than true, high. And if it is less, then it is low. Thank you. I'll continue with compass error next. Till then, take care.